Hello everyone. It's quite a lot of people. Are we all ready for the next one? So just to introduce ourselves, I'm David Edwards, Solutions Architect here at River Island.
I'm Peter Flood, Microservices Engineer.
Busy drinking a beer, obviously. Let's move on. Our talk today is going to talk about transformation at River Island that's been occurring over the last few years, but we want to give a very specific viewpoint from one particular team, which I'll get onto soon. So just a little bit, who are River Island? I'm sure everyone is familiar with River Island. We're a fashion retailer. We were founded by Bernard Lewis in 1948, and we started out selling fruit and vegetables and knitting wool, and that moved onto fashion, women's fashion, and we created the people that are old enough, the Chelsea Girl and Concept Man, and that merged in 1989, so 30 years ago this year, to River Island, and we've been a successful bricks and mortar retail business now for the last 30 years. We finally went online in 2004, which is a little bit late, but we got there in the end. And we now consider ourselves a digital-first business. So what that means to us is, agnostic to channel. We consider ourselves an omni-channel business. But conditions are tough out there, and we have to compete on two fronts. So I'm sure everyone is aware, retail business is struggling. Select just recently went into administration. So we have to ensure that we can remain competitive on the bricks and mortar physical retail, but we're also competing against the new breed, which is the digital pure plays. So the Misguideds and the ASOS and the Zalandos of this world. So it makes our job doubly hard because we need to make sure that we provide systems that allow us to support our physical retail business and innovate in that area, but also be able to compete with the digital pure plays. So, what did the flow of work look like for the IT department before our transformation journey began? Well, it's very much waterfall driven. So the what and the why was established by a get-together of senior business stakeholders and IT managers, and they would decide what's going to get developed and effectively how much that's going to cost for the year. And then the IT department would embark on a huge a requirements gathering exercise and a big tech design, and inevitably that would result in a big analysis or a big requirements specification and a big tech design specification, and that would be handed over to a project team that were mobilized to deliver that specific project that would be responsible for the delivery. And quite often that was in cahoots with a vendor. So back then, we jumped into bed big time with Oracle and SAP and other partners. And then we would hand that over. We would hand that over to a development support who would be responsible for the ongoing maintenance of anything that was built by that particular project, operations support that would be responsible for deploying that into said infrastructure, and then we would have infrastructure support that would be responsible for ensuring that things keep the lights on ultimately, and they would rinse and repeat that over and over again. The team was quite small, and what that meant over time was that tech debt was piling up. We were never spending any significant amounts of time paying down that tech debt. Systems were becoming ever increasingly unreliable and volatile. And simple work, just even the simplest thing, was becoming cumbersome and hard. And we relied on a few subject matter experts, individuals. So something had to be done. So our CIO, Doug, joined about 5-6 years ago, and things started to change. That was effectively the start of our transformation journey. And the first thing he did, as most CIOs do when they join a company is they reorganize, and people leave voluntarily and involuntarily. So that was the first thing. And he formalised our IT operations at the moment, at that time as well. So he introduced things like application support and IT operations with the service desk, etc. He also introduced some managed services. So up to that point, all of our production services were run on-prem. And he decided to delegate that out to HP as a partner, managed in Stockton and Tees as I said, as a managed service. He also created a PMO function, which allowed us to start to think about the ways that we work with our business, which is very, very separate at that time. IT was just considered a cost center. So back in those days, we also made our first steps into cloud. So we took our website at that point in time, lift and shift, and we deployed that into AWS. And then about 2-3 years ago, which is when I joined, we started our agile transformation. And agile transformation was projects were still prioritized through portfolio, but they were delivered in an agile way, and teams were using a combination of agile Scrum, XP, and Kanban to deliver. We also created our first agile operating model, which was split into 4 phases. So ideation, which is very much about understanding the breadth of the requirements, but not significant depth. Discovery was understanding just enough depth to get going. Implementation was obviously about getting going and actually delivering. And then support was how we operationally support any of these new services that we'd build as part of that project. So over those last 2 or 3 years, we've been working that way, but we've been looking to mature our agility. So where are we now in our transformation journey? So now we are trying to move from project-based teams to value-led product-based teams. And what that means to us is we're funding the team, not the project. And what we want our product teams to do is to work a lot more closely with the business to deliver incremental and continuous value to the business. We also want those product teams to adopt their own technology strategies that can be delivered alongside the value that we add and deliver to the business. Ultimately, we want teams to be empowered to make their decisions, but also be accountable for those decisions. And we want to provide the environment that allows them to be completely autonomous, which leads us on to adopting our DevOps culture. And a DevOps culture for us, if we was to put it very succinctly, means the product team is responsible for building it, shipping it, owning it. And at the same time, the team is always looking to improve on the 3 ways. Now, we're here as a DevOps community. I'm sure most people have read these books. If not, highly recommend them. But the 3 ways, fast flow of work, fast feedback, and continuous experimentation and learning are something that the team takes to heart and always looking to improve on. And ultimately, we're trying to keep it lean. So, we spent time making sure we understand the value chain. We try to eliminate waste, eliminate toil, add quality in from the start. Look at how we create MVPs, etc. So enter Silver Bullets. Silver Bullets are the name of one particular team. The name was given as a little bit tongue-in-cheek because back then we were talking to the business and we were talking about microservices. Business would use the microservices word very loosely as the solution to everything. So we took the name Silver Bullets because microservices to the business was the solution to everything. And the team started because it needed to deliver a project, and that project was to replace our existing order management system with a new order management system. But over time, we changed from a project delivery team into a product delivery team, and that domain was order, and that was orders coming from our web channel, but also orders coming from our retail channel, whether that was sales and returns. And the team is responsible for all states in the order life cycle. So that could be new orders coming from those sales channels right through to pick and pack and dispatch and cancel, and click and collect to customer return, etc. So the roles that we adopted in that team, so we had a delivery manager, we had a solutions architect, and we had a business analyst. And those roles were shared, so they weren't 100% on that team, but they were focused in that particular portfolio. We had a shared Scrum Master or Agile coach, and then we had microservices engineers. We had what we call core engineers, which very much work in our heritage estate, automation test engineers, and our core test engineers. What you'll notice is there was no dedicated PO, and that's because that role was filled as a continuum by the solutions architect and the business analyst. And we had no need for a technical lead because our engineers were proficient enough working in collaboration with said SA and BA to make the appropriate technical decisions for the team and ensure value was continuously delivered to business. In terms of the tooling selection made by the team, we were building services in AWS, and Peter will talk about those in a little bit more detail shortly. We adopted Golang as our primary language to build application services. Our UI development was React.js and Redux. And we used Terraform for infrastructure as code. Challenges we had as a team was bimodal IT or multi-speed IT, and that was mainly because we were accelerating quite quickly building new microservices, but we had to depend on changes made to our core heritage estate, which were at a slower pace for reasons. So managing the dependencies between those two was quite challenging at times. So before I pass on to Peter, I just wanted to talk about some of the team's architectural principles. So the first one was we wanted to break down the existing legacy monoliths. So we had a huge ERP system which started out as from JDA as a retail merchandising system, but over 10-15 years it was bastardized and lots of things were added to it. So we wanted to start to unpick the hairball, and as we unpick that hairball, start replacing that with microservices, and we've been doing that. We also wanted to decouple our systems from that same ERP system. So before we started, all orders were orchestrated through our ERP system. So in the event our ERP system went down, we were unable to pick our orders or pack our orders or dispatch our orders. So we've done a lot of work in that area. The other thing we were keen to work on is expose our business events. And what that means is any significant business event that occurs in that particular domain, the order domain, we want to expose in a public medium and make accessible to internal and external services. So examples of business events would be new order, validated order, dispatched order, cancelled order, returned order, etc. And we would make those order events available on, in our example, a Kinesis stream, but could be on an SNS topic or a SQS queue. We also wanted to make our data easily accessible, both in its raw format and its latest state. So in its raw format, we were very keen to start persisting all of our events as it transitioned through the states in its raw format, and that formed our data lake, and we wanted to make that easily accessible by internal, external partners. And a use case for that was all of this sales event information. We were allowing access from a machine learning partner that we were working with that provides us demand forecasting information. We also wanted to make easy API access to the latest state of orders, so single view of order, if you like, and we built what we call backbone services for that, and Peter will talk about that in a little bit more detail shortly. We wanted to be cloud native, so anything that we built new was built in AWS. And lastly, we always look for operational simplicity. So as a team, we always preferred serverless, but we also were not adverse to building services in ECS as well. So over to you, Pete.
Thank you, David. So first, I want to talk about how we process web orders. Here we see the key order events, new orders, valid orders. Items get picked. Sometimes they don't because we're out of stock. Orders get dispatched. Items get cancelled. Not all orders have all the events. Click and collect orders arrive in stores to be collected. Then people collect them. Sometimes they don't collect them, and the store has to return them back as uncollected. And finally, we hope this doesn't happen too often, because if we did, we'd be in trouble. But obviously, items come back to the distribution centre as returned. David mentioned the business events. All of these are the business events that are key. We store them all in S3. S3 is particularly good for this. We store them all in the same bucket, which is really key. We store them by event type. They're partitioned by date, which makes them more readily available. S3 is really important because we can expose events to selected internal and external third parties in a very granular way. We can give whoever needs access only access to the data that they need and no additional access. And S3 is so good and so cheap, we actually store everything twice. We do that because PII is a real big thing these days. Turns out that pretty much only the fraud team needs access to names and addresses. So most people, when we expose the events, we scrub the data. This is a very simplified version of our app. Essentially, orders come into API Gateway, which, for those who are unfamiliar, is a REST API. AWS provides it. It's just configurable, and all API Gateway does in our case is simply puts the events on a Kinesis stream. Kinesis is akin to Kafka. It's a message broker, and we have this pattern of data on a stream, and then we process it via lambdas. The lambdas tend to do one of three things. They put the data in S3 buckets. They may process the data, enrich it in some way, or transform it in some way. Those lambdas tend to stick it straight onto another stream. And other lambdas maybe call REST APIs, send the data here, send the data there. The lambdas pull batches of events from Kinesis in sizes of maybe 10 or 100. When errors occur, if a lambda pulls 10 events, the first 9 may be processed successfully. If the 10th throws an error, we simply reprocess the whole batch. That's very deliberate. Idempotence is key. When problems happen, essentially everything comes to a halt. Human intervention is required. Sometimes the service that the lambda's sending the data to goes down. If it's coming back up, then nothing to do. In other cases, if we can't unmarshal a payload, we simply use the dead letter queue pattern and just send it off to S3 to be processed later. Lambdas don't do everything. We tend to have the simple logic within lambdas. For more complex logic, we use stateful services. In this case, order history, which is a traditional REST API. It's got an ALB in front of it and a database behind it. We have a few of these. For deployment, we do full CI/CD in Dev and staging only. We actually have around 45 lambdas, lots of streams. This application diagram here, architectural diagram, is very, very simplified. When we deploy to prod, all deploys are one click, but our code is split over 10 different repos. For dev and staging, it's not so much of an issue. When we have errors and stuff, obviously it blocks stuff. But in prod, we don't want errors in the live system. For example, if order history has a problem, customers can't collect orders from stores. And as I'm sure you can appreciate, customers want to be able to take their parcels away. So because we don't continually deploy, we have code in master which is undeployed. To let us know about that, we've built a Slack bot which essentially nags us daily and tells us, indicates we've got stuff to deploy. We do this. The deploy process has a lightweight Git tag. So every time we deploy any repo, we tag the commit with a prod tag, and then any commits ahead of that turn up in here. And it's a very effective way of letting us know how far, what's outstanding. And obviously, the more code builds up, the bigger the risk of a deploy. So we do deploy very regularly. This is a DevOps talk, so of course we have to have a Grafana slide. This shows a problem we had over the weekend. These lambdas consume events from Kinesis streams, and like I said, when they encounter errors, they just simply reprocess. Everything is idempotent, which means that we are potentially sending duplicate events downstream. We embrace that. We do it deliberately. We know that all the downstream services can handle that. It is by design. So here we see some errors. We can see lots of lambdas retrying. And the key event here is the iterator age. Because the latest event processed is becoming older and older and older, the iterator age is going up. This weekend, a downstream system, they tried to migrate a database to a new server. It turns out the firewall rule that was in place was removed without notice. And we only found out when we tried to switch it. So that explains why we're getting 500 errors from downstream. But ultimately, they roll back, and because the system is just sending those events again and again and again, once the problem's solved, everything rights itself. So here's an example in Dev of some commits. The lines you see, maybe some of you are familiar with, Grafana annotations. The first deploy here creates a problem. The second deploy is irrelevant. Essentially what's happened here is we're adding some authorization to an API, and it turns out we added write order, not save order. So of course throws errors, nothing happens. We figured out the problem, figured out what it is, and then as soon as we deploy the correct code, the events get processed, everything's happy. The failure mode here is key. Essentially, one of two things happens. The problem writes itself, or we move the events off to the dead letter queue, as I said before. So I want to talk a bit about logging. These are some log groups that we have, lots of them. The problem with a CloudWatch is easy to log everything. The problem is that you can't actually search across log groups. There's no way of seeing all the events that are happening in the app. You can only click into one of these and see the events for that group. And it gets worse. Some systems, within a log group, you have log streams. This is the one for order history. You see there's lots of streams. You can go into an individual stream and see the events for that stream, but when you have 2 containers running a service, you're only seeing the events for a single one of those containers, which isn't that useful. You can search, in theory you can, but it turns out in our case it's not very useful at all. You search for something and it takes minutes to actually return. You just see a spinner. So that's not really very useful. So we thought we'd try log aggregation to Elasticsearch and Kibana. That works very well in our case, certainly. Obviously it's nothing new, but finally we do this. What we do is we essentially have CloudWatch subscribers that post all the logs to a Kinesis stream. There's again at the end of that Kinesis stream there's a Lambda, it picks up all the events and just sends them to Elasticsearch. So here now we see all the different log groups. We can suddenly see all the events in chronological order in one place, which is a massive improvement for us. I want to talk a bit about structured logging. These two ways of logging are essentially equivalent. You can put the facts into the log message, but that makes extracting them out difficult. Structured logging is more about, the log message there failed to send event. Yeah, that was the problem. But there's obviously key value facts essentially about the logs. And once you extract those out, Elasticsearch laps them up. And once you have those events, here we can see we've got order ID, store ID, stream name, any facts we choose to log. And key here is this particular Lambda is sending events to S3, so we're actually logging here the path in S3 that the events are going to be stored in. So once we actually have that information, we can get towards internal tooling. So now we can actually input, we built this internal system, we can input an order ID and find all of the events that relate to that order ID over the time span that it happens. So this is really key, and we're talking about web orders here, and this tells the whole story. An order was made 16th of April, it was validated, it was dispatched 17th of April. We captured the money once it's dispatched. We don't actually take the money because obviously some items might be out of stock. If it's out of stock, we're not going to take the money for those items. Payment, the payment calls are asynchronous, so we've got the call here. It's taken, 2 minutes for payments to actually come back and let us know that the money's been taken. It's click and collect, so it's arrived at the store the next day. And once it's arrived at the store, the customers then, the following day, has come to collect it. And then some 3 weeks later, they've returned the item. And then within 1 second of us being notified that the item has been returned, we've refunded the money back to the original card. So, going back to what David was talking about, extracting this process from the legacy app, it has been decoupled. All of the processing that you saw in that diagram, if any element of that of the architectural diagram, if any part of the app goes down, all the other parts of the app remain up. So we can continue processing. Any one small piece of functionality has a problem. So we've decoupled, we've exposed the business events. All of the data is accessible. Obviously, it's in AWS, so it is cloud native. And the operational simplicity is in the failure modes. The failure modes, when a problem happens, everything comes to a halt. We alert on it. We've built it. We're on call, so we get alerted. Alerts go to the business to tell them of the impact of that. And essentially, sometimes it does require human intervention, but for a distributed complex app, the failure mode remains the same for virtually all the failures. So we do have operational simplicity. So thanks for listening.